Today we're going to do inverse equations, learn how to draw the graphs, how to restrict the domain, and how to find the domain and range of a function. Given an equation of f of x is equals to minus 3x plus 4, and want to find the inverse of the function. So the first thing is we're going to write the equation as y is equals to minus 3x plus 4. And the second thing is we're going to interchange the x and the y. So where there's x we put y, where there's y we put x. So in this case we're going to say x is equals to minus 3y plus 4. And then the second thing is I'm going to write it in standard form. Write the equation in standard form of y is equals to, so you're going to say x minus 4 is equals to minus 3y, then divide by minus 3, then you have y is equals to x minus 4 over minus 3, which you have y is equals to x over minus 3 minus 4 over minus 3. Therefore y is equals to x over minus 3 plus 4 over 3. So this will be your inverse. Consider also having f of x is equals to 2x to the power 2. So you're going to write it in y is equals to 2x to the power 2. And then you interchange your x and your y. So you're going to have x is equals to 2y squared. Then divide by 2. Both sides we have x is equals to y squared. So x over 2 is equals to y squared. And then now you're going to write it in standard form. So you're going to say the root of both sides, y is equals to plus minus root of x over 2. So this will be your inverse. Consider now having f of x is equals to 2 to the power x, which you'll write as y is equals to 2 to the power x. And then you interchange your x and your y. You have x is equals to 2 to the power y. And then now, because these are logs, where if you had something like x is equals to b to the power y, therefore your equation will be y is equals to log of bx. As you can see, this is the base, and in logs this is the base. So you're going to do the same thing here, meaning that you're going to say y is equals to log, so your base is 2, you're going to put your base there, and then x. So this will be your inverse. Inverse function. Consider a function of y is equals to x squared, which when you draw in your Cartesian plane, it will look like this. Now, the inverse of this function is the root of x, which for you to draw it, you must first have the line of y is equals to x, like this, y is equals to x. And then now, to draw the inverse, you'll get the reflection of this one, which is this line here, and then the reflection of this side of the parabola is going to be this one. So now this will be your inverse function. Now, because the inverse of the function, which is this one, it's actually not a function, we say that because if you are going to draw your vertical line test, then it will touch at the 2 points of the function, 2 points of the graph, making it not a function. So now, for us to be able to make it a function, we must restrict the domain. So we must restrict the domain of the original function, which is y is equals to x squared. So let's say, for example, we have the function here of y is equals to x squared. And if we're going to restrict the domain to x is greater or equals to 0, it means that we're going to choose the x values from this point going to that direction, which are positive. Then this side here will disappear. And then now we are going to we're going to reflect it about the line y is equals to x. So if you check from the original graph there, that will be the line of reflection, and then now it will look something like this. So now your function has been restricted, and then if you are going to choose to restrict it from x is less than or equals to 0, you'll draw your function here, your original function y is equals to x squared, and you're going to choose one side because x is less than or equals to 0, which means we'll start from 0 to the negative side. Then you remove this side here, and then now you're going to write its reflection. So you know you have your y is equals to x line, and the reflection of this about this line will look something like this. Now your inverse is a function when x is greater or equals to 0 or x is less than or equals to 0. Now we want to find the domain and range of the function. So let's say we have y is equals to x squared, which if we draw, it's going to look like this. So the domain of this function, we're going to look at the x values from the left hand side to the right hand side. So if you check the function, it has negative x values from this side to positive x values. So it means that the domain, its x is the element of real numbers, or you can write it as from minus infinity to positive infinity, because the function comes from a negative infinity to a positive infinity. Now, to find the range of this function, we're going to look at the y values. Because this is the y, this is the x. Going down here, we have the negative y values, and going up, we have the positive y values. So as we can see, the graph starts from the origin, which we have 0 and 0 as coordinates, meaning that the x value is equal to 0 and the y value is equal to 0. So now the range, we're going to look at the y values. So where does the graph start? It starts at y is equal to 0. So in this case, we'll say the graph starts at 0 and then it goes up to positive y, right? So to a positive infinity. Or you can say graph is greater or equals to 0. Now, to find the domain and range of an inverse of this function, which is y is equals to the root of x, if we are to draw this function here, it will look something like this. So to find the domain and the range of this graph here, so the domain, if we check the x values, these are the negative x values, and these are the positive x values. These are the positive y values, negative y values. So now, as you see, the function starts from the origin. We have 0 and 0 and goes to the positive side of x. So for the domain, we can say that it starts at 0 to positive function here. So x is the element of this here. And then now for the range, as we said, it starts from the origin to the positive side. So if you see here, these are the negative side of y. This is the positive side of y. So the function starts from a negative infinity of y going to a positive infinity of y. So if you can check here, you will notice that in our original function of y is equals to x squared, the domain was negative infinity to positive infinity. And in this case, for the inverse, the range is negative infinity to positive infinity. And then again, for the range of the original function, it's 0 to positive infinity, and the domain is 0 to positive infinity. So there's an interchange. Hi, thank you so much for watching. Please subscribe and hit that like button below.